Okay, welcome to our first lab for AGEC on 410, Ag Policy. This is our third class meeting of week 3. So we are replacing what is scheduled to be an in-class period with this lab. The idea being we could go to a lab session and I could get in front of the room and give some remarks and maybe some instructions and have you follow along. But this gives us, one, we don't have a lab scheduled for this class, a lab space, but it gives us the flexibility to let you do things in the way you're most comfortable, using your own computer, wherever that is, and we don't have to worry about what's been installed in the labs and so forth. So that's how we'll do this. At least for this first lab, we'll definitely spend a little time on the Monday after the lab is posted. So this is posted for our Friday class. We'll spend some time Monday discussing it, just making sure everybody had a reasonable experience playing the video back with the volume and following along, and if there's some things I can do. There are a few limitations. One is the spreadsheet size is kind of locked in. It is not convenient or not even simple for me to change and zoom in, so you'll see me sort of stop the machine or stop the record, or stop doing anything and just leave it frozen there for a second and try to point out where the formulas are when we use formulas, and try to read and use my pointer to point you to things. So as long as you're following along, hopefully you can see it on your own machine. But some of the Excel dialog boxes get small, and there's no really good way to blow those up. They tend to stay the same size even when you try to narrow the field of the video recording. So the basic approach here, though, is that I'll talk through some things, I'll pull up my spreadsheet, and then I'll actually go through at the very end and run at least one or two of the scenarios just to show you what we're doing. And at the end of this, there'll be a quiz posted. That quiz is basically just a check. Can you go through and do the 4 scenarios we see? Because I want to be able to use the spreadsheet and the sort of tests and the scenarios, maybe not the exact same scenarios, to play with some other ideas as we go forward thinking about alternatives. Okay, and so that's our strategy in this lab period. Okay, so just as an overview, we want to think about policy and ag policy as an economic intervention. It has a lot of different contexts. So there's certainly the most common one is sort of a public economics. Is this the best use of the public's tax dollars? Okay, or what's the opportunity cost of devoting $1 of taxpayer money to this project versus another one? And that's certainly not the one that we're after here. That's too big picture. It requires much bigger models than we're going to encounter. When you think about ag policy, one of the sort of dominant themes, if you read Knudsen chapter 7, or at least just look at the parts that I've tried to talk about in the past week, the level of distortion has been sort of a center stage idea. How much influence do the policies or the subsidy programs have on what producers decide? And so one of the things we might do in a sort of starter version of a policy model is think about, how does policy impact producer decisions? And we might bridge that and go on and say, how does it impact well-being? Okay, and so we'll try to hit on both of those today. And so that's sort of how our lab is focused and what we're going to build up to. Today's lab, we are not going to be looking at sort of real policy instruments. We're going to try to put into a spreadsheet form or a model form the kind of ideas I was talking about in our most recent lecture about expansion of production. Okay, but if we add to that some ideas about profit, revenue, and cost, that sort of last piece that I was covering. So we're going to check 4 kinds of policies. You'll run 4 scenarios against a base case, 2 output subsidies, 2 input subsidies, and that's really as far as we want to get in this lab. Okay, so from the class notes that I talked through on the most recent lecture, we did some specific profit models, right? We said profit is a function of the production technology and prices for outputs and inputs, and you could solve that problem with a simple sort of calculus application. And then we did a graphical solution to the two output problem with the producer possibilities frontier. And then at the end, as we left class, I wrote on the board this idea, the idea that some sort of general model would take into account the net returns to the operator, right, the sort of target of farm policy, the net returns, and those returns you might think of as a revenue function or a revenue component that depends on prices and quantities of output plus whatever exogenous factors there are, and that could include all the technology pieces plus whatever impact the policies have on those. The cost sort of component or the cost function, which might depend on the input price, the input quantity chosen, and then any other exogenous factors, which again could include technical constraints, technical advantage, and also any policies that cause you to want to use more or less. So like if you had a regulation on how much fertilizer could be applied, it would show up there. And then the last piece of the general function is the government payment function. It could depend on the current price, the current quantity output, the current input price, the current input quantity, or some exogenous factors. And we're going to see this become more and more important as we get to more realistic policies. So our goal is to get a generic look at how policies can impact this sort of income or net benefit equation through the revenue, cost, and government payments. But eventually we'll see that if there's no interaction, right, if the government payment formula doesn't cause a change to sort of the market revenue or the market cost, then we're okay just writing models that look at what are the government payments. If you wanted to, and so here you can see those notes, and then I say if you wanted to think of this in a word calculus, the last thing I did on the board, then you could think about it as the left-hand side, taking the derivative of the left-hand side with respect to sort of the output quantity would be the easiest thing to think of. What's the marginal profit from an additional unit of output? And the calculus-based sort of marginal economics we've learned tells us, well, that rule says that marginal profit should go to zero. If you're finding the best solution or the best choice for a producer, it's to exhaust all of the marginal gains. And so that means push production, push it all the way out till the last unit of revenue is exactly covered by your last unit of cost, okay, last marginal units. And so that's where you get this piece, just these two terms here together, marginal revenue equals marginal market cost, and that gives you, if the marginal profit is supposed to be set equal to zero, it means these two things must be exactly equated. Well, if there's a marginal government payment, and it depends on the output unit, right, depends on the output level, then that's in addition to the sort of marginal gains. So you have the marginal market revenue. That's why I'm putting market in both of these terms. If the marginal government payment is in addition to the profit of the producer, and it can be changed by the quantity of output or the quantity of input, either one, then it must be the case that having this additional revenue from the government drives up the marginal benefit side and forces you to a higher level of marginal cost to balance those two out. So if you're going to still make this marginal profit equal to zero, this additional term from government revenue forces you to find a higher marginal cost in the solution, and marginal cost goes up with output. Okay, the way you get more, the higher next unit of cost, the higher marginal cost, comes from additional output, which means traditionally, if the government payment shows up over here as a positive with respect to the change in output, then you are increasing output in response to this. Okay, so that's just sort of the theory, the marginal theory I'll keep bringing up, and this is sort of the functional approach that I'm going to use as we build these models, and you'll see it as you move into the spreadsheet. So maybe it's okay if I open the spreadsheet just for a second here. Okay, and so if you think about it, I have a revenue block, a cost block, and a government payment block. And so when I do this, I'm breaking apart sort of the market revenue side, the market cost side, and then government payments. And then down here we'll calculate the profit as the revenue block minus the cost block plus the government payment block, and we'll get a solution that we're going to identify right there. You see I have a few question marks built in that we're going to fill in at the end of towards the end of this lab. We'll fill those in and then run a couple of the scenarios so that you get an idea of what's going on. The block that I haven't talked about is that production function. Okay, and so this first piece here gives you a given production function that we'll talk about in that next slide, and it just says that if you look at this, x is the unknown. Okay, so if you highlight this, so a formula would come up if there was a formula here, but there isn't one. So x is the unknown. It's the choice variable that we're going to let the producer, when we solve this problem, we're going to let the producer, or the solver, choose x to maximize profits subject to the production function. And this production function is a specific type. It's called a Cobb-Douglas, and its function is written right here. And so I'm trying to highlight this formula so you can see it. It is cell B3, which is 100, and it says it's alpha. That's the name of the parameters, alpha. So it's alpha times the input level raised to the power of beta, or in terms of this spreadsheet, it's B3 times B6, the choice of input level, raised to B4, this value for beta. Okay, and I've put those in as 100 and 0.5, and we're just going to leave those in. When we come to class the next time and I start playing with this some, we'll see how this production function changes, if we want to, how it works if we change it. And of course you're welcome to change it, but be sure you get all the scenarios done with 100 and 0.5, because the multiple choice quiz that you do at the end of this is going to depend on you having those set. So they're, leave these blocked off and just follow along. Okay, so we have that formula there, and then we have formulas over here. It says the revenue block just says take the output price. Again, I'm giving you this output price to work with. Take that output price in D3, multiply it by the output level, and that'll give you the revenue. In the cost block, take the input level, multiply it by the input price, which is F3. Right here, I'm giving you the input price as a given value. Multiply it by B6 over here, the choice of input, and that'll give you the total costs. And then over here we have something a little more complicated that I'll get to as we get there in the notes. Okay, so we start this thing off with actually a production block. So in Wednesday we just wrote f of x. In the most recent lecture we just wrote f of x is the production function. It tells us the quantity conversion, right? So if you take this much input, run it through whatever your technical process is, how much output do you get? And so here I have that, y is equal to f of x, but we can't get by with this generic f of x. We need to give it a format, and that's what this is. This says alpha is equal to some parameter, some y is equal to some alpha, which is a parameter, multiplied by x raised to the value of beta. And alpha is 100, beta is 0.5, and I think if you plug these numbers in, you would see that 250,000 units of input generates 50,000 units of output. Yeah, so something like that. Anyway, so the production block is already built out for you. The unknown is x. Y will be known as soon as we choose the level of x. Okay, so y is a formula in your spreadsheet. X is something we're going to let be unknown, and we're going to let solver find that for us. The revenue and cost blocks we've already looked at. but they're just here to track these components of profits separately, okay, for now. And the reason this would be to track these separately is we're going to have output price. We're going to have policies that affect the output price, policies that affect the input price, and we might want to see how they have different effects. Either way, we might want to track this. We're probably not going to do much with those, but other than be sure that we are getting everything calculated in an orderly fashion. Now we're going to add some components to those blocks to track scenarios. So you can see I've already ran one solution in my spreadsheet to get these examples where I had 10 and 50,000. If you open the spreadsheet, it'll be blank. But what we're going to do after we solve the initial solution, we're going to take that base case and we're going to record it, and then all of our policy scenarios where we actually introduce some policy variables, some subsidy rates, we're going to need to add to the revenue block and the cost block this sort of tracking. So we're going to record the base case value here, and then we're going to put in a formula for the percentage change here. And since this is in the notes right here, and we have the formula here, 100 times the new value minus the base value divided by the base value. So this is, if you get it right, 100 puts it on a percentage basis, new value minus base value gives you the change, and then the base value gives you the base for the change, right? So this is the change over the original, which is a proportion. And if you ever want a proportion or a fraction converted to percent, just multiply by 100%. I'm not using the percent sign there. But let's go ahead and fill in our spreadsheet, our first run, to get the base case right now. Okay, so this is where it's going to be. I'm going to go a little bit slow to make sure we see this. But if I've done this correctly and you just download the spreadsheet directly, I'm hoping the solver will look correct for you from the start. Okay, so we have a formula here for profits, and it says take D4, the revenue, subtract the cost in F4, but add to that H11 whatever government payments we have, okay, to get the total profit from production. That formula is connected to costs, to revenue, to government payments. The revenue formula is connected to the production block by Y. The cost block is connected to the production block by X. Sorry. Can't get it to, here it is, yeah. So connected through B6. Sorry. And connected through B7. Okay, so everything here, if we start making changes in the production block, we'll see differences show up in revenue and cost, and maybe in government payments, but hopefully not yet. And so let me do this. So the only thing we could change right now is X, the only thing we're allowed to change. So let's put in a value of just 1 and see what happened. So all of our formulas adjust. We get 1 unit of input, 100 units of output. At an output price of 10, the revenue is 1,000. The input price is 1. The total cost is 1. The profit shows up as $9.99. And we didn't get anything in government payments. And that's because down here, all the government payments are set to 0 right now. Okay? And that's the way we want to do it for our base case. If we make an adjustment and change that to 100, so 100 units of input raises the profit level. But you might notice the profit per unit of input is falling. It was $9.99, now it's $9.90. And so you can see where we're headed towards a solution. Well, we could keep doing this and keep working to find out where we're headed, right, with the best profit, and eventually you find a profit that it kept going up and up and up, and then it started to fall. But that's not the way we want to do any of this. We want to use Excel's built-in sort of calculus routine. It takes all the work away from us. So with that, let's go to data, And out here to the right of the data tab, so follow me, follow my mouse. The data tab is 1, 2, 3, 4, 5, the sixth one over, and then it should open this up for you. And all the way out here I have solver. If you don't have solver, if it doesn't show up for you, then I'm going to take 1 minute here to show people how you might find it. So go to File, and then, File is the first menu over here to the left. Go to File, go all the way down to the bottom where it says Options. Click on Options, and then go to Add-ins. Okay, so when I clicked on Options, I get all of this general formula proofing. Well, down here in the bottom section, it says Add-ins. And if you click on Add-ins, you get this one little Go button right here. Now, you can see it right there, but just go to this one. And this says the Excel add-ins, and these are packages, I guess is what they would be called. These are software packages that are built into Excel. They're installed with Excel, but they're not ready to run yet. Okay, you have to choose to turn them on. And so this Excel add-ins, if you click on Go, it opens this little box right here. And so there's the Analysis Tool Pack. There's one that works with Visual Basic Analysis Tool Pack if you want to do Euro currency tools. But this last one, called the Solver add-in, is the one you want to check the box on. Okay, so mine's already checked because it's installed, and if you can't find Solver, it must be because this is not checked. Click on it, click OK, and you should see it do a little Solver install. It shouldn't take long at all. It should be already there. Right? There shouldn't be any need for a disk or anything. If anything like that happens, just hold off and we'll figure it out Monday. But it should just blow it into your data tab. And so next time you come back up here to the home and all these little tabs, when you go to data, you should be able to go all the way out to the right and find Solver. Okay, so if you have Solver installed now, I'm going to assume that everybody was able to get through that and find it. Then you should be able just to click on Solver, and what it does is it opens up this menu. And when I'm talking about how I can't make this bigger for you, this is what I'm talking about. This is as big as Solver gets. I can try to lower the screen, and maybe I will in the future, but traditionally it just shows a smaller screen width. So I'm going to read everything off to you here. But if you look at Solver, it has something at the top, and it says Set Objective. And then it says, what do you want to set the objective to? And then it has a block called By Changing Variables. Okay. So at the top here in the Set Objective, that's where we put our objective variable. Okay. So I'm going to click on this. These little red arrow buttons over here to the side let you opens this and lets you choose where you're going to pick what cell in the spreadsheet is going to be the objective cell. And for this, we're going to choose B11. Okay, that's where profits are calculated. And I've already got that clicked. But if it isn't showing up for you, choose B11 right here where it says the intersection of profit and solution, or in column B, row 11. Click the little red button, it takes you back out. And then in this row, we're going to set it to a maximum. Okay, so profit should be maximized. That's our economics rule driving all this. And then down here, it says which variables are choices. Okay, so by changing variables, that's the area where you put variables that are up to the decision maker, or in this case, that Solver's allowed to make adjustments to find the highest value. And so I'll click the red thing again, and you'll get this same sort of dialogue. And then the value I've chosen, the cell I've chosen, is B6 right here. Okay, so it's the input level. Output is a function of input, and everything else is connected either through the output choice or the input choice. So this one choice, X, is going to drive our solution going forward. The last thing, last two things, I guess. Down here's a checkbox that says make unconstrained variables non-negative. Hopefully that's checked by default, but if for some reason that box isn't checked for you, go ahead and check it. Just click on it and it'll toggle on and off, but be sure it's checked. And then it says select a solving method. If you've done this in some other class, maybe 352, you might have used the simplex LP method, but that won't work. That's a linear method, and we need something that'll solve anything. And so we're going to use what we call the GRG nonlinear solver. So you can read about it here. Solver problems that are smooth but nonlinear. So that this production function we've put together is a smooth kind of curve. It's a smooth production curve. There's some options you can choose there, but I don't think we need to look at those yet. And so everything here is set up. So we've got the objective. What direction are we trying to drive that objective in, and we're going to maximize it. What choices are there available? Only one, the input level. And then and what about unconstrained variables? Let's make them non-negative, right? That means they can't go below 0. And then what solution method? Let's use this nonlinear. If you click on solve, then you should get a solution. And that solution should throw up a dialog box that looks like this. It'll say keep the solver solution, which is okay. And then it'll say something about the answer report, the sensitivity report, the limits report. We don't want any of that. We're not going to mess with that's all about the shadow solution. Maybe at some point we'll look at it, but I don't want to yet. Not in this lab. So click on OK, and everything sort of locks down. Now this gets us to the point where we have a base solution. So if there's no government policy in play, and the price is 10 for output, the price is 1 for input, and this is our production technology, then the best choice is use 250,000 units of input to make 50,000 units of output, and we'll get a profit of $250,000. If you want to check that that's best, put 251,000, and you'll see that profits fall. Put something like 249,000, and that's not 100%. That's not a pure proof, but it should be enough to convince you that going above and below 250,000 units on the input side, going below will lower your profit, and going above will lower your profit. So we found the peak profit level at this input choice. Now our story is just to go through and record our base case. So this is our no policy solution. It's our base case. And so I'm just going to go through, and what you have to do here is the temptation is to say this is equal to this, or even to copy it, and you can't do that because that is a formula. Okay, so that is determined by multiplying D3 and B7, and the fact is we really just want everything we do after this. We want it to say the revenue in the base case was 500,000, and similarly we want everything we do here to say the base case had $250,000 in variable costs. Okay, so I'm just typing those numbers in there, and that's what you'll want to do too. And now it's just left to put in our percent change formula, and since the solution right now is the base case solution, the percent change formula should show us 0 when we finish those. But let me type that in. So it's going to say equals 100 multiplied by, put a parenthesis, an open parenthesis, and we said it's going to be the solution value, or the new value, minus the place that we keep the base case. Okay, and so this is where we are keeping, this is where we recorded the base case value, so anytime we change it, it'll look at the base case and compare to that. So we close that parenthesis, and then we need to divide by the base case as well to get that percentage change formula correct. And it shows up as 0. Now, because I've sort of stacked these two things together, the revenue block and the cost block, you can just copy and paste that formula. Unfortunately, it's going to change the color, it looks like. Let me find a green. Oh, or maybe find an orange, I guess. Who knows? There it is. Okay, so if you don't want to cut and paste it, you can always highlight this information, you could highlight the text and paste that in as a formula, or you just retype the formula in here using the correct cell references. Okay? But here's what it needs to look like. It needs to be 100 times the new calculated value minus the base value divided by the base value. Okay? And when we get that, we'll interpret it directly as a percentage change. We have one more place down here where the base case is important, and we're going to put it in. So that's type 250,000. That was the profit in the base solution. And then we'll have to do that formula again. Equals 100 multiplied by, open parenthesis, new profit value, or the calculated profit value, minus the base profit value, close parentheses, divide by, yeah, it's not, divide by the base profit value, so C11. And you get a percentage change of 0. Okay, so we have all this set now to run a simulation. You can come back up here and you could start to change things. You could change, a normal thing to do in a production class would be to change the output price by a small amount or the input price by a small amount and see how that impacts. How does a market adjustment impact our producer here? You might change a production parameter by a little bit and then measure these percentage changes and see how that impacts our producer. Anything you want to do, as long as you're resolving the model using solver and getting the best solution, then you have a direct comparison. But that's not what we're going to do. We're going to do something just a little bit more complicated, not particularly complicated, but we're going to do something a little more complicated with our government payment calculator. Okay, so that's what we just finished. We just ended up putting in those base cases and percentage changes everywhere they belong. And now it's time for us to look at our government payment block. So what I have done for the government payment block is to calculate a total government payment at the bottom, but it's built up from a few different things. So the first thing is, let's get the payment per unit input, and that's the X. The G is the government, X is for input. And so what do we get here as a per unit government payment that is tied to the use of input right here? And then here we're going to get a government payment factor that is tied to output. So this is the payment per unit output. And so these are 0 in the base case because there were no payments involved. And then here, if this is the payment per unit of X, then the total payments based on input would be this factor multiplied by total input use. So when we look at the spreadsheet again, you'll see this is a formula, and this is a formula as well. This is a formula that says what are the total payments on output basis. So it's going to be this factor multiplied by whatever the total output of the problem is to get a dollar amount. And then the total government payment is going to be a formula that just says give me the total payments that are tied to input and the total payments that are tied to output, and we'll calculate those two. Okay, and so just a little bit of background on government payments or tax and subsidies in sort of generic types, the way we're going to do them in this lab. Okay, so calculating the government payment rates that go in this block. Right, so the payment per unit input, the payment per unit output are going to be whatever the scenario says are the per unit payments. And those will be calculated in that lower block that we haven't looked at yet. But there's two sort of basic types of policies that we should consider right away and get accustomed to. One is the ad valorem tax or subsidy. So an ad valorem policy takes a percentage rate. Okay, so it says use the percentage of the value to calculate the subsidy or tax. And so the easiest thing to do would be think about if you, Social Security tax is 8.5% of your income up to a certain dollar amount. But anyway, that's an ad valorem tax on your income. Or the easier one to think about is the sales tax. So sales tax If you're not at the grocery, or you're buying clothes, whatever. If it's not sort of grocery non-prepared foods, sales tax is equal to 7% in our municipality here. And so it's basically whatever your bill is, or whatever the price tag is on some item, assuming it's not a food item. It's it's 7 cents for every dollar that on the price tag, right? So you can't just go from the price tag, and so that's what we call an ad valorem tax, and you can do a subsidy that way as well, right? So if you've got subsidized for every $100 you spent on healthcare, if you got a 2% subsidy, right, that would be like getting 2% or $2 back for every $100 that you showed as an expense. Towards healthcare. And of course, there's some places, right, where that works. You get that money back as a tax credit or something. And so that would be how you would think of an ad valorem subsidy, based on the spending level or the income level or the earnings or whatever, based on the price, right? So it's a percentage relative to the price. The counter to that is just a specific amount. A specific rate goes directly to the physical units, okay? And it says if you buy a gallon of gas, it doesn't matter what the price of gas is. You pay, I don't know what the road tax is, but there's a maybe 15 cents a gallon tax on that gallon of gasoline. And so you pay the same tax whether gas is expensive or whether gas is cheap, right? And so that's a specific tax levied per unit, okay? So it's like an add-on to the price. And so if you went in, if you look at the gas station price for your gasoline, they report the price plus the tax, right? They give you whatever it's going to charge you per gallon, and that's tax inclusive, right? So you don't see the tax as separate. Another case in agriculture, I think it may still be the case. Every unit of cattle sold, you paid $1 per head as a checkoff or something like that. I can't remember exactly what it was, or if it was $1 per hundredweight. But either way, it was $1 on the physical units, not $1 for every $100, right? It's based on the physical units. So basically what we have is ad valorem are tied to the prices. So you're going to be a percentage for every price unit, and here it's going to be a constant amount for every quantity, okay? So one is looking at the subsidy here could be tied to my revenue or my costs. Here, the subsidy or tax is going to be tied to my output or my input, right? So it's either quantities or dollar figures. Okay, and so that's what we have for our government payment sort of calculations down here. So the government payment block links down to these, right? And we have one is the government payment factor on output that's ad valorem, on input that's ad valorem, and then we have the specific rate on output and the specific rate on input. Okay, so these are four options, and the way we're going to do this is a mistake right here. This is changed in your spreadsheet, so it should be 0.1. But these scenario notes column is just the four scenarios, so you don't have to look them up or try to remember what they are. I just type these four things in. We're going to run these one at a time. So you're basically going to say 0.01 here, everything else 0. Then you're going to move 0.01 here and turn this one back to 0 and turn these to 0. And then you'll move, this should be 0.1, and it's changed in your spreadsheet. You'll put that in there and turn the rest of them off, turn them to 0, no taxes, no subsidies. And then we'll put this one, copy this one over here. That'll be our four scenarios that we run. So that scenario notes is just a column to remind me and you of what policy experiments we're supposed to run through and compare each of those to the base case. We're going to run them one at a time, and we're only going to run those, we're only going to put those rates in. And then we'll erase the rest of them while we're running it. Don't do anything with this. So only use the box. Right? This is the box to enter this ad valorem rate and this ad valorem rate and this specific rate and this specific rate. The cell right below it is a formula, so it's time for us to look at those. Let me bring the spreadsheet back to the front here, and let's take a look here. So, the easiest way to do this is to let me just say the first scenario is going to be to type 0.01 here as the ad valorem rate on output. Okay, so that's a 1% rate. So it says 1% of the value of output is given to you as a subsidy. Okay, if you earn $10 from the market, you get an additional 1% as a subsidy. And so what this does, this formula that I built in right here just says take the subsidy rate, B15, and multiply it by D3, the chosen price. And so that gives us a per unit. So what this factor is doing is just converting the ad valorem to the per unit rate. Okay, and so as long as the price is set at 10, then that makes the comparable rate per unit 0.1. And then you see it gets taken from here and copied up here. And you see this is a formula that says give me both, right? So you could run an ad valorem and a specific subsidy to output from this formula. It says take B16 and B22, and that gives you the total sort of government payment per unit factor, okay? And calculate those two together. And that's how we would calculate right here. H4 times B7, the total government payment is equal to this factor, 0.1, multiplied by the total revenue. Okay? So 10% of every dollar you earn, or sorry, 1% of every dollar you earn comes to you as a government payment. So 1% of the total revenue must come back as a government payment, and that's what that's calculating there. H4, right here, times B7, right here, on a per unit basis. Okay, so you're getting 1 cent, you're getting 10 cents per unit of output, and it all shows up there. Okay. Now let's switch from that. So I said let's zero these out when we're not using them. So that takes away, right? Takes away all this sort of connection that connects through this factor here. And let's punch in this, the 1% ad valorem rate on input. This says you get a subsidy when you get your bill for inputs as $250,000. You will get a subsidy equal to 1% of that outlay, $2,500. Okay, and so it does that by calculating the GH factor here. So 1% of $1 is just 1%, and so it calculates itself. Right here, this is a formula that says take 0.01 and multiply it by F3, but we made the cost, the input price, $1, so it shows up as 0.01. Okay, zero that back out, and then move down here, and we'll see the last one we're going to test. Just test what the formula is. So if you look at this, it goes from, this is saying a specific rate, 10 cents. Every unit you sell, we give you a 10-cent subsidy. So it's a dollar, at the tenth of a dollar, or 10 cents per unit subsidy. This was a 1% subsidy on the value. This is a 10-cent subsidy per unit. And so when you look at this formula, you'll see it says just copy what's above. Okay, and so this is the simplest formula here. It just says to sort of balance everything out, I use two cells. But the specific rate is just what we want, right? We're going to use specific rates up here. So that means, if we zero that back out, that means really what's going on in this first two, in this calculation and this calculation, is I'm converting the ad valorem rate to a per unit basis, and that's why I'm allowed to add those together when we get up here, right? So this GX factor is B18 plus B24. Well, I'm allowed to do that. Oh, that looks like a mistake. Yeah, that's a mistake. I'll fix that. So that formula, so we're supposed to add, if for some reason this doesn't show up as fixed for you, when you get to it, it should be B19 and B25, right? That's where we want to add, because this is the ad valorem rate converted to a specific level, a specific factor tax or subsidy, and then this one's already in that form. And so that's how that formula should look. And let's look at this one again just to make sure I got it right. Yeah, so this one is correct, B16 plus B22. So I'll fix that in the spreadsheet that you download, but be sure that you look at that and know the difference. Okay, so with all that, what are we left to do? Let me pull up my PowerPoint just to make sure I got to the end of what we're doing. So it's just the base cases. So objective for lab is to get through these scenarios, see how everything works, see how the calculations work, because I want to kind of use this as a framework for us to do a little bit more with policy and analysis, but also when we expand and start thinking about, should this policy, should some specific version of a policy that we're looking at, should it impact producer decisions, yes or no, then I want us to test that out. And I want to use a spreadsheet that looks like this with a government payment block, a revenue and a cost block, and so that we can see all these pieces and kind of make up our minds about how we're going to model these things and if we're doing it correctly. So you'll have 4 scenarios to run through. The quiz will just say what's your answer for something on scenario 1, scenario 2, scenario 3, and scenario 4. But they are 1% ad valorem output, 1% ad valorem input, so you could compare those, right, as sort of equivalent percentage policies on the output and input side. And then 10% per unit input and output subsidies, you could compare those as sort of dollar outlay, right? So those two might match up together. Completing our spreadsheet, we've already completed some of these percentage change formulas, but we're going to set up and run the scenario. So I'll run a couple of those to get us going here in the last couple minutes that I have. Okay, so we're in our spreadsheet. The simplest thing is to just start with the first one here. So we get this ad valorem rate, 1% subsidy to output. We copy it. It does the calculations, but this isn't the solution yet, right? It changes everything, and that's interesting. But what we really want to do is resolve. Okay, so go back to your data tab here at the top. Go over to solver, and solver should be set up. We want to run the exact same solver technique. We're going to maximize profit subject to maximize profit by changing the value of the input, changing the level of the input, I guess is a better way to say that. Click on solve, and it finds you a new solution. We're not going to keep any of that stuff. And we get something here. We say that we should now be using 255,000 units of input. That'll generate 50,500 units of output. And then here you get the percentage change. So costs went up by 1%. Costs went up by 2%. Revenue by 1%. That's because the government payment is making up some part of this, right? So the government payment has moved in. And the real story here is we've expanded. So 1%, a 1% ad valorem subsidy in these scenarios, right? When this is the output price, this is the input price, and this is the production technology, causes us to use much more input, and it boosts output. It boosts output across the board, okay? And so if you add that up over a bunch of producers and they all qualify for the subsidy, we're seeing a big shift to the supply curve, which is where we are eventually headed with this 2 labs from now. Okay, so what do we get for a scenario 1? We might just put it here and say the rev percent change, the cost percent change, the prof percent change, and we might I don't know, whatever else you want to record. I guess the output change would be, or the output level, I think that's what I'll just record. But actually, let's change that. And so I'll just make the quiz be sorry, I'm having trouble deleting here. Let's go with output, and that'll be the output level. And then let's go with prof percent change. Okay, so we'll record those two things, and then if you keep track of those as you go through your scenarios, those will be the things you can do with the quiz. But I want you to look at everything as you run it. So scenario 1 gives us an output level of 50,500 units, and the profit percent change was 2. Okay, so that's a 1% adjustment to the output price. Okay, so remember, set this back to 0 before we run any other scenarios, and then we'll go 0.01 here. Okay, so now we have a solution that's acting against the input price, not the output price. Go back to Solver, Data, the Data tab, all the way to the right on Solver. Just go straight down to Solve and let it find you a new solution. So on the input side, the input subsidy side, let's see what we get. So this is scenario 2, if you want to think of it that way. The output level is now 50,505, and the percent change in profit shows up as 1%. Okay, so compared to the base case, profitability is a little less, and so this is one of the sort of stories we need to figure out what's going on. So we're not getting as much profit, but we are expanding output, right? So the profit level is not going up as much. So the boost to output was much more important to us, and I think if you look at the production function, you can figure that out, because every unit of input gets raised to this. I mean, if you don't know, that's the exponent, but it's also taking the square root. So you're only getting the square root of the benefit of the input, right? And so that's why we might expect it to boost output more, but actually change the welfare on the profit side a little less, right? Because it's just not as big a boost to the government payment side. So it's a cheaper source. Okay, so just run through those. Really, the whole thing, really the whole goal of the lab. Be sure you understand this, or that you're sort of taking this in. And again, you can record these two things all the way down through the 4, and you'll have enough there to finish the quiz. The point of this is to get how we might do some calculations down here that give us different alternative scenarios for government payments, and we connect it to the producer decision framework by using this government payment block and the production block, right? The technology is connected to the revenue and cost already, but the revenue, cost, and government payment block get connected through this profit equation. Okay? And so that's the whole point of this kind of simulation and getting an idea of what we're going to do, because we want to think about government payment per rate calculations that are more complicated than just 1% or 1 penny or 1 dime per unit, something like that. So run your 4 scenarios, collect these 4 scenarios of output, and the changes and the levels that you record, and then proceed from that to the quiz that follows this lab. And that quiz is just a multiple choice thing that you go in, it gets scored automatically, and it just shows that you've completed this with the been through the process, so that we're ready to move on. When we get to the 3rd lab, you'll have a written output, so we'll have something more like a homework attached to that one. All right, so thanks for your attention. This was about on time with what a normal class would be, and I hope it works for you and you're able to follow along and gather from this. But be sure, make notes on any questions you might have, and come ready to talk about those in Monday's class.